the equipment. So yes, as was mentioned, I'm going to be talking about traits and remnant vegetation today. And this is work that was part of the vegetation program that has been spoken about earlier in this session. So you've already heard some of the introduction and some of the work that was done, but I'll focus specifically on the vegetation component of it and talking more specifically about traits. And I'd like to acknowledge my contributors, Nigel Willardby, Sasha Jelinek, Ross Meffin and Matt White as well. So to introduce, determining the success or otherwise of restoration activities is a key requirement for land managers and ecologists. And restorations programs require clear goals, appropriate indicators and well-planned assessments. And this is what we've tried to do within the vegetation program, although I've come on board at a later stage. So traits or characteristics of species are increasingly being used to investigate the functional recovery of ecological communities. This is also relates to the resilience of those communities, which I'll take you through. So what are traits? So as I've said, that they're characteristics of species, and some of them we've actually just heard in the previous talk about pollination and those types of things. And also traits have been divided into two particular types, and I think that's rather helpful in terms of effect traits, which are, as you say, your pollination or your shading ability of your particular taxa, or actually also things like nitrogen fixing and things like that. So they're things that are actually within the community and how the organisms affect each other. So response traits are more about the environment. They're more about how the traits that the species have to cope with various perturbations in the environment. So this could be in terms of, say, flammability, or their ability to tolerate heat stress, or their ability to tolerate grazing. And these things, both effect traits and response traits, contribute to the functional diversity of the system. And functional diversity, in terms of the overall variety of these different traits, contributes to the resilience of the system, their ability to withstand these different types of perturbations. And there's different measures of these things, and throughout this talk I've chosen to use a measure called functional dispersion to actually investigate functional diversity. And this is a multivariate technique that looks at the distances within a species based on its traits. And then also will look at overall at the community and how it also tracks in terms of its traits, and that's through using community-weighted means. So the restoration goals and translating them into trait targets. So the overarching restoration goal of this project was to restore a functionally resilient community similar to remnant sites. And underneath that, I broke that into some sub-goals. And these were to restore the lost community, to restore a desirable resilient community, and to control and exclude introduced species. And some of these goals actually interact with each other. But in terms of the trait targets that we were able to, that come out of these different goals, these were to restore the traits of reference communities, to restore functional diversity which conveys resilience, as I've already mentioned, and to identify the traits of invasive species which can be used to target new plantings and control measures. And this is following a recent paper by Daniel Laughlin in 2014. So this is the area in which we worked, which is you've already seen earlier in this session, but if you've come late, here's a picture of the Lower Lakes region. And you can actually see the different survey sites that we've looked at over the different years. All of the sites were assessed in 2015, so we've actually measured them all at once in different vegetation communities. And there were 4 different vegetation types, which have been alluded to before. In terms of the overall assessment of vegetation types, we're only looking at 4, which is why you'll see they have some odd numbers. And we also looked at multiple sites in each vegetation type, and then there were 9 replicates taken within each site, and the assessment was using a Braun-Blanquet cover sampling technique. And as I said previously, all sites were recorded in 2015 for this particular work. So the vegetation types, just briefly, that I looked at were pink gum, coastal wattle mallee, mixed eucalypt type, mixed eucalypt woodland and mallee, and also non-eucalypt woodlands. And the numbers are important for the graphs that follow. So vegetation type 1, 4, 5 and 10, that's what these are referring to. So these are the particular traits that I did use for this study. So we had a whole suite of different traits. Some of them were response traits and some of them were effect traits. Predominantly they were response traits because we were particularly interested in looking at the effects to those different types of perturbations, as I mentioned, including fire, drought and browsing. So this is kind of a picture to look at what we were trying to go from and to. I think this is actually this is not an initial planting. I think this is one of the older planting sites. But you can see that we're trying to get to, we're trying to get to the picture on the right-hand side from something that looks a bit similar to the picture on the left. So this is the overall species analysis that I did. I used principal coordinates analysis to have a look at the different vegetation communities and the different years of planting. This graph in particular is looking at the different vegetation communities over time. The open diamonds are actually 2015. And the other symbols represent the other years. So you can see actually that interestingly the most recently planted sites were the most similar to the remnant sites down in this corner. And we can see over here I've done an overlay with Pearson correlation of the species over these sites. You can see that interestingly it's actually a lot of the introduced species that correlate with the revegetated sites and a lot of the native that associated with the remnant sites. And that's not unexpected. Now what I did try and do in this next graph is have a look at the trajectory over time, and this might be a little bit difficult to see. But I did actually find that there was a significant relationship over time as was shown in the last example, that there was an increasing trend in dissimilarity of the species, the revegetated sites to remnant sites within the different ecosystem types. And I think this could potentially be related to differences in time. So it's actually it's a story that shows that perhaps we're actually getting better at doing revegetation over the 5 years of planning rather than there being any other significant change. I mean, there was mention that there were differences in how which grasses were planted and whether or not they were planted over time, and also the type of weed control that was done, I think, is an important thing as well. So this is the functional dispersion that I mentioned earlier in the talk, which I'm using as a measure of our functional diversity. You can see we actually have some differential results. You can see that in ecosystem 6 we've got an increasing trend over age since planting, and in ecosystem 1 we've actually got a decreasing trend over age since planting. Now, I think the same sort of things could be at play here, and in particular, one of the large things that may be influencing our functional diversity results is the presence of weeds. And I'll show you why I think that's the case in the next few slides. So here you can see I've actually this is a PCO where I've taken just the trait information, and I've actually looked at the difference between introduced and native species just within their traits. Now, what you can see is that at the top right corner, there's actually a whole swathe of introduced species that have no native analogue. So they're quite different from the native species in terms of their traits. And I think this is important and potentially why we're getting differential results in terms of our functional diversity, because it's the functional diversity that's being conveyed by the invasive species that's driving the changes. Because what you can see up here then is where I've got these, I've got the traits overlaid. You can see that the traits that are associated with the weeds are short longevity, so annual species. They're very much they're killed by fire, so fire K means killed. They've got a short time to maturity. They occur in nutrient-rich soils, and they're non-woody. On the opposite side of that, which is related to more of the indigenous species, you've got that the species are not killed by fire, that they're found in more poor soils in terms of nutrients, and they're also more woody. Now, this is the community weighted means analysis that I spoke about earlier. This actually shows us in trait space the different sites that we measured. So if you think and you know what a normal community analysis looks like when you're looking at it based on species, this analysis is showing the difference between the sites based on the underlying traits of the species. And you can see again that we've got these here in the open squares are the sites, the remnant sites, and over here these are the planted sites. And over here you can actually see, in terms of what correlates with those sites, similar things. So over here you can see that the revegetated sites are associated with being killed by fire, the traits being killed by fire, short longevity, nutrient good. The similar things are coming up. And on the opposite side also too, that we've got that the species in the remnant sites are not killed by fire. They have much longer lifespan. They're found on nutrient poor soils. So you can see that the differences between the sites are likely to be driven by the invasive species that are within them. Just excuse me, I need to have a drink. So I think that's really interesting because it's telling us, I think what it's likely to tell us is different strategies that we can use to manage these sites. Since we've got a whole swathe of species or a whole swathe of traits that are killed by fire and things like that, or that are a nutrient good soil, we can actually look and say, well, perhaps that would actually be a good management strategy to use in some of these sites, perhaps prior to preparation, that we would use fire, and that it's likely that the native species will not be sensitive to those measures, but that the introduced species will. And so there we're able to, through using this kind of a trait analysis, we're able to pick out some of those key management strategies. And so overall, in terms of the outcomes of the work that we've done so far, I think in terms of these trait targets that we had, to restore traits of reference communities, to restore functionally diverse systems which convey resilience, and to identify traits of invasive species which can be used to target new planting measures and controls. I think in terms of those outcomes, there's still a long way to go in terms of restoring the traits of reference communities. But 5 years is really a very short time period. I heard Corey Bradshaw talking this morning when he was talking in terms of a similar restoration project where he was unsure that he'd find any outcomes within his lifetime. But I think it also really picks up importantly on what Hayes said at the beginning in terms of his talk, that it's really critical that we continue to monitor these sites so that we can pick up that recovery and so that we can see the change. We've done some really good groundwork, and we can see that yes, there are differences between our remnant and re-veg sites, both in terms of their species composition and their trait composition, but we need to be able to track that over time. And without ongoing monitoring, we are unable to do that. So in terms of the functional resilience as measured by FTIS showed differential results in terms of the different communities, and this warrants further investigation, I think, to look more tightly at why that is, what other species that are in there that are providing those traits, and is it because we've done some sort of particular management to one of the communities but not the other? Did we actually put some of those grass species back in one of the vegetation communities but not another, and that's changed our trait trajectory? But again, it could also just be that this is an early period of time and the species are in flux, and so we can't expect there to be really seeing trajectories in this short time period. And And finally, that the use of traits, I think that one of the really cool things that came out of this, that we really can see, that the use of traits has enabled us to identify key weedy traits, and therefore help us derive management strategies which will target the species present rather than using general practices. So yeah, thank you very much for listening.
Thanks, Sally. Unfortunately, we've run out of time, so there's no time for questions. Last talk for this session is going to be Narissa Habe from